Sooner or later, when you're programming against the SDS2.NET API, you'll need to work with members, plates, angles, welds, or bolts. Well, how exactly do we do that? Well, ladies and gentlemen, today we answer that question. So without any further delay, let's slide into this. Now that we have our job open, we can get a list of member handles in order to get our members of our job. Now, a member handle is an object that allows us to retrieve a member in two different ways. But let's first get a member handle list. So we'll say member handle list handles equals job.members. Now, from here, we can iterate over our member handle list. So we can say for each member handle, I'm just going to call it MH for short, in member handles. Now, earlier I said this allows us to get a member in two different ways. But first, we need to add a new using. So go up here. I'll say using design data.sds2.model. Then we go back to our for each loop. Let's say member brief. Now, a member brief object is extremely useful, especially if you're wanting to read data. It's the fastest way you can retrieve data about members in your SDS2 model. However, it comes at an expense. That being, you miss three properties and you don't have access to most of the methods. But let's go ahead and finish writing our line of code. So we'll say member brief called MB equals member brief dot get, and we'll pass in the member handle. So now, if we say MB dot, we can see everything that we have access to. We have access to the ends, a bunch of the properties. If you care about the section size of the shape, you could go like shape section size. So you have all your read properties. So member briefs are really good about that. The other way is just by getting a member. Now, when you get a member, it is slower, but you have access to all the properties of member brief, plus the three additional that you're missing, and you have access to all of the methods on a member. So to get a member, we'll say equals member.get, and you pass in the member handle. And we'll say member dot, and if we filter on functions down here, we'll see that we have a lot more options here than we do if we use a member brief. Now, in order to retrieve materials, you first have to get a member, but then you have to be able to grab the materials off of that. So we'll say a material list ml is equal to member dot get material. Now, a material list will contain about 27 different types of materials. Today, we will be mostly focusing on two of them, one being a rectangular plate and the other being an angle. Before we can access our materials, we first need to create a for each loop over our material list. So we'll just say material in ML. So now we can go ahead and set up our switch statement. So we'll say switch, and we will be switching on the type of our objects. So we'll say switch on mat, and we'll say case rectangular plate, RP. And then we will also say case angle. Alright, so now that we have our switch set up, we now access the properties of each of the materials we want. So on rectangular plate, if we wanted to get our thickness, we could do that. Or if we wanted to get our length, we have the order length, we have the part length. We also have width of the plate. You really have everything you need in order to get information about your plates here. And then with angle, right, we have a lot of the same properties. You have the length. You can view the shape dot section size, so that we know what type of angle it is. You really have all the access to everything you need to know about the parts inside your model. Now, if we want to get information about our welds and our bolts that we have in our model, you can do it a lot like how you get the materials. So here, we can say a weld list. We'll call that WL is equal to member.get welds. Now, just like in the fashion of our materials, we'll just say for each weld W and our weld list. We can say w.arrowside.weld type in order to get the type of weld that we have. So, like for example, if we have 12 on this, or view the source, we can see that we have all the different types of welds that we know that we're working with, and that is great. And then for bolts, it's accessed very much in the same way. We can say bolt list bolts equals member.get bolts. And from here, we can set up our for each loop. We can say bolt B and bolts. And then we have access to all of our properties here. We also have some access to methods, like adding nuts, adding washers. However, for that, you'll need a transaction, and we will be covering that in a later video. So make sure that you are subscribed and you hit the bell for notifications so you don't miss that video. Okay, so let's jump back into our project in 3, 2, 1. Now that's a lot better. So before we go any further into working with our materials, we'll first need to make a few new models for our user interface to display them. So let's go to our models, right click, say add, new item. So here we'll be choosing a class, and we're going to call this estimation member. And we go ahead and add that. We'll want to make the class public. And then we're going to need to add several new members to it. So to add properties to a class, you can either type it all out, or you can type prop tab, and then we will start to add our properties here. The first property will be of type string, and it will be called section size. Then we'll add another property. This will be a double. This will be length. We'll add another one. This will be an integer called count. And then we'll add one last one, which will be a double. And this will be cost. Okay. Alright, so that sums up our estimation member. Now we need to add a few more classes. So we'll say model, add, new item. We'll call this an estimation plate. We'll go ahead, we'll make this a public class. And then we're going to go ahead and add a couple of properties. The first one being length, so we'll have a double. Then we'll need another double for width. And then we'll need another double for thickness. Then we'll need a string for grade. And then we'll need an integer for count. And then another double for cost. Okay. We also want to create an estimation angle class. We'll go ahead and make this a public class too. So very first property is going to be a double. And we're going to call this order length. We'll create a string that will be section size. Create another property string for grade. Whoops. Then we'll have another property that is an integer. This will be count. And then we'll have another double, which will be cost. Alright, save that. Now we need to create two more, one for welds and one for bolts. So we'll say add new item. This will be estimation bolts. STI estimation bolts. Bolt. We'll make this a public class. So we'll need a double. A double that is going to be called diameter. Another double that is length. Then we'll need a string that is grade. Then we'll need an integer for count. Then we'll need a double for cost. And then we just need to make our welds. We'll say new item. This will need to be a public class too. For welds, we'll want a string for type. We will want a double for length. We will want a double for size. We'll want an integer for count. And a double for cost. Alright, that sums up all of our models that we'll be needing for our estimation portion of the application. So we can go ahead and close out all of those. So now if we go back to our main window.xaml.cs, we'll want to go ahead and refactor our lesson code and put that into its own method called getMaterials. So here, we'll say private void get materials. So we'll just take this, we'll copy it, well, we'll really cut it, paste that. So now that we have our getMaterials method set up, we will want to create a list of estimation member. We're going to call this temp members for grouping. Okay. So this list here, it's going to hold every single member in the job. So we don't need a member brief, so we'll go ahead and we'll delete that out. Then after we get our member, we'll want to have a new line here. We'll say temp members for grouping dot add new estimation member. And here we can start to fill out our object and our object initializer. So the section size will equal member dot shape dot section size, and the length will equal open parentheses member dot ends sub 1 dot location minus member dot ends sub 0 dot location dot length. There we go. Now, one thing I forgot to do is we need to actually check to see if the member has a null section size. Occasionally you'll find that there'll be a null shape on an object. That means we just can't add that one. So what we want to do is say if member dot shape is being equal to null. Then we'll copy this up here. Okay, so now that we have our members filled out, I believe in learning by doing, so go ahead and try to figure out the rest, and I'll see you in just a minute. Alright, welcome back. So let's go ahead and finish filling out the rest of our objects. So as you can guess, we'll need a few more lists. We'll say list estimation plate, temp plate for plates for grouping. There we go. Also need a list of estimation angle, we'll also need a list of estimation bolts, and then lastly we'll need a list of estimation welds. Alright, so now that we have all our temporary lists made, let's go ahead and fill them in. So for the rectangular plate, say temp plates for grouping dot add new estimation plate. Here we'll say that the width is equal to rp dot width. We'll say that the length is equal to rp dot length, and then we'll say that the thickness is rp dot thickness, and the grade is equal to rp dot grade. Grade dot name. There we go. Alright, now we just need to fill in the angles. So I'll say temp angles for grouping dot add new estimation angle. Alright, we'll say grade is equal to a dot grade dot name. Then we'll say that the order length is equal to a dot order length, and a dot section size is equal to a dot shape dot section size. Now we need to fill out our welds. Welds can actually be a little tricky because welds have two different sides. They have the arrow side and the other side, so we need to check both. So say if w dot arrow side is not equal to null, and if weld dot arrow side dot weld size is greater than 0, say welds, let's say temp welds for grouping dot add new estimation weld. Here we say type is going to be equal to w dot arrow side dot weld size, no, weld type dot toString. Then we'll say that the size is equal to w dot arrow side dot weld size. We'll say length is equal to w dot arrow side dot weld length. And now we just need to do the same thing, but for the other side. So we'll just copy this. We'll paste it. We'll say other side. So if the other side is not equal to null and the other side dot weld size is greater than 0, then we'll just replace all these arrow sides with the other, and we have our welds taken care of. So now let's work on our bolts. So from here we'll say that temp bolts for grouping dot add new estimation bolt. Here we'll say length is equal to b dot length. Okay, the grade is equal to b dot bolt type dot material. The diameter is equal to b dot diameter. And I actually forgot to add a property to our bolt, so let's go back to that class. So go to estimation bolt. Let's just add a new property here. This will be a boolean, and it's going to be is tc for is tension control. Go ahead, we'll close that. We'll get back to our method here. Is tc equal to bolt dot is tension control. And then cost and count we don't account for right now. So perfect. We have this taken care of. Now that we have all of our materials in their respective collections, it's time to whittle those collections down so that way we only have one material per group. So the way we want to do that is we want to use some link statements to do so. So first we want to say for grouped members equals temp members for grouping dot group by, I want to say such that new object x dot section size x dot length. So what we just did here, we said, hey, take our temp members for grouping, group them by this new anonymous object, which is just going to be comparing section size and lengths, and make groups for me. So I want you to go ahead and take a stab at doing the rest of the group bys on the rest of the objects, and I'll see you in just a moment. Alright, so I'm sure you've got all your grouping done, but if not, we can just follow along. So here, we'll say var grouped plates equals to temp plates for grouping dot group by x such that new object, we'll say x dot length, x dot thickness, x dot width, and x dot grade. Perfect. I'll say var grouped angles equals temp angles for grouping dot group by x such that new object x dot grade, x dot order length, x dot section size. Now we need to group our welds. welds, temp welds for grouping dot group by x such that new object x dot length, x dot size, and x dot type. And the last one's for our bolts. Temp bolts for grouping dot group by x such that new object x dot length, x dot is tc, x dot diameter, and x dot grade. Okay, now that we have all of our grouped materials, we will then want to create new temporary lists, iterate over each of the groups, and make the count of each of them. So here we'll say list estimation member, say temp members equals new list. We will then want to say for each var grouped member and grouped members, we'll then say temp members. Actually, we will then grab the very first instance. So we'll say that estimation member em is equal to gm dot first or default. That if em dot is not equal to null, we will then say that temp members dot add. Actually, sorry. We will then say em dot count is equal to gm dot count, and then we'll say temp members dot add em. Okay, that's great. So let's go ahead and fill out our other types, and I'll see you in just a moment. Alright, welcome back. So I have gone ahead and I have pre-filled out everything. I figured you guys didn't want to watch me copy and paste and change a bunch of names several times. So let's go over what I did. So first I created the new temporary collections for plates, angles, welds, and bolts. I then, just like the members, iterated over each group, counted how many items were in the group, assigned that count to the very first instance of the group, and added that to the temp collection. So we can see we did that for plates, we did that here for angles, for welds, and for bolts. So we're now at a point in time where we can start to test our code, but before we can do that, we need to do a few more things. So let's go ahead, just add a console.writeLine, and all we're going to do is use this to set a breakpoint. So set a breakpoint there. Then we need to have a private job, so that way we have a job that once we select, we can look at everything inside of it. Then inside of our selected job here, we'll say that job is equal to job.findJob. We'll say value.jobIdentifier, job.open, and we'll say get materials. Okay, so at this point, make sure you're running in 64-bit, and then we'll say start. Once the application's up and running, we'll drop down the drop-down, we'll pick our sample application, we hit our breakpoint, and then if we look at our temporary collections, we'll see that we have 11 members. If we look at our plates, we have 11 A36 grade plates for there. If we look at our angles, right, for the first one we have 8. For our temporary welds, you can see that we have several there. And then for our bolts, we have all of our data there too. So it looks like all our code is working perfectly. Don't forget, you can always hand count everything in your model to verify that our code was working correctly, but in our case it is.
While we take a fun adventure into the land of SDS2's drawings today, we still have a little bit more to cover. Next time, we'll be creating the user interface for our drawings. Thank you for tuning in, and I hope you have a wonderful rest of your day. Goodbye.